Welcome to this high-stakes explainer. Picture this. You're walking into the exam hall. The invigilator says, "You may begin," and you turn over the paper. Suddenly, you're at the table, playing the Cambridge Mathematics Examiner's game. And today, we are going to show you exactly how to play that game and win big. Think of this as your Casino Royale strategy session for the Cambridge exams. We are looking at subject code 9709, specifically diving into the mechanics of linear momentum, where P equals mv. But listen, the strategies we're unpacking today scale across the board. Whether you're working through 0580, pushing through 0606, tackling 424, 437, 4040, or stepping up to advanced 9231 and 9709, the rules of the game remain the same. This isn't just about reviewing a basic mathematical formula. No way. This is about understanding the psychology of the exam board, knowing exactly when to hold, when to fold, and when to go absolutely all in on your answers. We're going to decode the specific strategies that separate the top-tier candidates from the rest of the pack, looking directly at the theoretical foundations and the crucial examiner insights that you absolutely need to secure every possible mark. Let's get right into it. Take a really close look at this stark warning from the examiners themselves. When a senior examiner specifically flags linear momentum as one of the most misunderstood areas across the entire mathematics syllabus, that is a massive red flag. It proves the momentum is a trap, and we are going to learn exactly how to bypass it today. Let me introduce you to two types of students we see all the time. Let's call them Alex and Sam. Alex is the overloader. Alex sees a momentum question, panics, and dumps every single raw mathematics fact onto the page. P equals mv, kinematic equations, Newton's laws, just a massive wall of text and numbers with zero actual analysis. Then you have Sam. Sam is a rusher. Sam looks at the clock, completely misses the specific command word requirements like show that or evaluate, and just scribbles a final number. If you looked at their papers side by side, they are covered in red pen marks from the examiner. Why? Because they treat momentum as a simple plug-and-play calculation. It's not. It is a highly nuanced topic that requires immense precision, and a failure to grasp the underlying mechanics is exactly where candidates bleed marks. Today, we are going to fix those flawed answers right now. Here is your insider cheat sheet, your master blueprint for the entire session. We will walk chronologically through the exact sequence required to secure those top marks. We're starting with the momentum trap, identifying those red pen mistakes Alex and Sam made. Then, we build the core principles, diving into the assessment objectives. After that, we'll implement our 5-step methodology, unlock the ultimate method mark strategy, and finally, elevate your game with evaluative thinking. This is the exact sequence you need to conquer the paper. Let's move into Section 1, the momentum trap, and uncover the very specific, almost invisible ways students bleed marks without even realizing it. We have combed through years of Cambridge principal examiner reports to find the exact data on where things go wrong, and the findings are honestly mind-blowing. Okay, so the absolutely crucial point here is that you must avoid these top 3 mistakes if you want to protect your baseline score. Let's look at what Alex and Sam did wrong. The number one classic trap is using the wrong approach for the wrong context. Alex memorized the formula but failed to analyze the physical situation. Is it an elastic collision? Is it an inelastic collision where the objects coalesce? Alex didn't check, used the wrong approach, and lost the marks. Secondly, forgetting to check format and presentation conventions. Sam rushed to the paper, did the math perfectly in their head, but didn't write down the intermediate steps or the correct vector directions. If it isn't presented correctly on the paper following strict conventions, you lose marks. And third, providing answers that are not specific to the given context. Generic, textbook definitions do not score high in advanced mathematics. You have to tailor your response precisely to the data provided in the question. Moving right along into Section 2, Mastering Core Principles. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's establish the fundamental concepts and the specific assessment objectives you need to succeed before we start crunching the numbers. This brilliantly illustrates that momentum isn't just rote memorization. It requires a rigid, evidence-based approach to fully grasp the mechanics of the question. To beat the examiner's game, you need to understand the PEL framework, adapted perfectly for mathematics. PEL stands for point, evidence, explanation, and link. First, the point. You identify the core mathematical principle, like the conservation of linear momentum. Next, evidence. You extract the specific masses and initial velocities from the question. Then, explanation. This is where your systematic analysis comes in, setting up the algebraic equation with the correct positive and negative vector signs. Finally, the link. You link your final calculated velocity back to the physical context of the problem. Is it rebounding? Is it moving forward? Top students structure their mathematics answers using this exact theoretical architecture, proving causal relationships step by step. You must elevate your game from a superficial overview to deep analytical depth because candidates who reference cross-topic connections achieve significantly higher marks. This is where we leave Alex's strategy in the dust. The examiners have made it abundantly clear that they prioritize analytical depth. What does that mean for you? It means you can't just skim the surface of P equals mv. You need to demonstrate that you understand how linear momentum integrates seamlessly with other areas of the mathematics syllabus. How does kinetic energy change during an inelastic collision? How do kinematic equations tie into the objects before impact? When you can draw those cross-topic connections and show a holistic, deep understanding of mechanics, you instantly signal to the examiner that you aren't just memorizing, you are analyzing. All right, let's head into Section 3, the 5-step methodology. We are going to dive into the rigid, standardized, procedural framework, what we call the mathematics success blueprint, that examiners are desperately looking for when they grade your paper. We're going to take Alex and Sam's flawed answers and transform them right now. If you systematically follow this 5-step sequence, from deconstructing the data to executing with clear notation, you are playing the examiner's game perfectly. Step 1, identify key elements. You don't just read the question, you decode the command words. Does it say find, show that, or evaluate? Step 2, apply relevant principles using our Peel framework. Step 3, execute the analysis algebraically without skipping steps. Step 4, verify the results. Does a velocity of 500 meters per second make sense for a colliding marble? Probably not. Catch your mistakes here. And Step 5, present in format. By applying this mathematics success blueprint, we can take the red pen marks on Alex and Sam's papers and transform them into green check marks. It's all about systematic execution. This clearly outlines the exact data interpretation skills you need to execute Step 3 of our methodology without missing a single beat. In an exam setting, your first skill is extraction. You must accurately pull the correct figures, masses, velocities, directional vectors from texts, tables, or complex diagrams. Next is interpretation. You have to analyze the causal relationships. How do the forces during impact change the momentum? Finally, you must conclude by drawing evidence-based outcomes. You aren't just guessing the final speed, you are providing an undeniable mathematical conclusion based on the extracted evidence. This is exactly why rewriting your answers to fit this structure immediately adds marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, getting back to the strategy. Never forget Step 5 of the methodology. Your presentation must follow strict academic conventions to safely lock in the marks you've calculated. Examiners constantly report that students lose easily attainable marks simply because their presentation is sloppy. You must use correct terminology, you must clearly state your assumed positive direction, you need appropriate mathematical formats and clear annotation. Don't make the examiner hunt for your final answer. Serve it to them on a silver platter. Welcome to Section 4, the Method Mark Strategy. Now we are getting into the interactive workshop part of this explainer. This strategy is your ultimate safety net when the tension is high and the clock is ticking down. This is your absolute ultimate insurance policy. Showing your precise analytical framework guarantees that you can secure method marks even if your final calculation is totally wrong. Let's do a quick interactive workshop right now. Challenge 1, data scan. Imagine a complex mathematics data table on your paper showing particle collisions. You have a 60-second mental timer. You need to instantly extract the core trend. Are the particles moving in the same direction or opposite? Challenge 2, find the flaw. Think back to Sam's paragraph. Sam wrote P equals 5 times 10 equals 50. What's the flaw? No units, no indication of direction. The examiner commentary would give that 0 method marks. Challenge 3, speed writing. You have 30 seconds to write one perfect Peel paragraph. Point, conservation of momentum applies. Evidence, M1 is 5 kilograms, U1 is 10 meters per second. Explanation, initial momentum equals final momentum. Link, therefore, final velocity is positive 8 meters per second to the right. If you make a calculator error at the very end but have that Peel structure written down, the method marks will completely save your grade. Let's move to our final section, Section 5, Evaluative Thinking. This is where we build the ultimate winning hand for top-tier candidates and finalize the complete mathematics answering system.
To secure those very top grade boundaries, you must understand that the assessment framework is strictly split between descriptive, analytical, and highly crucial evaluative levels. Describing the problem only gets you the first 33%. Analyzing the data and running the calculations gets you the next 33%. But that final, vital slice, the evaluative level, is what higher order assessment objectives demand. This ties perfectly into our 3 rules that guarantee top marks. Rule 1, command word decoding, ensures you know what level you're operating at. Rule 2, Peel framework application, ensures your analysis is structurally sound. And Rule 3, the time management matrix, ensures you actually leave enough minutes on the clock to perform this high-level evaluative thinking at the end of the paper.
Top-scoring candidates constantly execute these critical analysis techniques to evaluate the quality of their evidence. When you are looking at a momentum problem, you need to actively question the assumptions being made. Are we assuming a perfectly smooth surface with zero friction? You need to identify limitations in the evidence. Maybe the mass of the connecting string was ignored. You should consider alternative interpretations of the physical scenario, and most importantly, justify every single mathematical decision you make with hard, empirical evidence. This evaluative mindset is what transforms a standard student into a top-tier candidate. It is the final piece of the mathematics success blueprint. As we wrap up this explainer, I want you to truly reflect on this core question. Are you actively analyzing the assumptions in your working, or are you just like Alex and Sam, blindly chasing the final number? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.